we're gonna use the rule to find the derivative. Okay, derivative rules. The first one is called the power rule. The power rule applied for the power function. You see x to the power. The power is the real number. Okay, so power as a real number. Okay, not the power as the x. Okay, so the formula to find the derivative is the power, bring it down to the front, treat it as a coefficient, and the new power is from the original subtracted by 1. Okay, for example, let me make some room. So for example, if you have f of x equals x to the fifth, so the f prime of x equals the number 5. So I consider r equals 5. Okay, so going to be 5, bring it down to the front, multiply by x to the power 5 minus 1. So the derivative is 5 multiplied by x to the fourth. Okay, so that's the use of the power rule or the derivative rule for the power function. And the next one, the next one is the, what do you call, the equation of the line. Okay, so I bring it up to get some more room to put on the example. The equation of the line. So this is one of the examples of the power function where the power is 1. So the power, that's the power is 1, or r equals 1. And we don't really need the derivative rule for the equation of the line because we know the slope is m, and we call m is the derivative or the f prime. And the f prime is the same as y prime notation here. So we can pull out the value right away as the value of the derivative. F prime is the same as y prime because we do based on the equation y equals f of x. So then the y prime is the same as f prime. Okay, for example, well, just to make a connection with the derivative, if you have y equals negative 2 over 3 times x plus 5, so our case, the m is negative 2 over 3. Therefore, the derivative of this function is negative 2 over 3. Okay, very straightforward. But now you apply to whatever that you already know. And then more special case, for the case that you are dealing with the constant function, I'm going to write a note. This one is called the constant function. The constant function, that means when you plot the graph, you have the horizontal line. Think about the slope of the horizontal line. What would that be? The slope would be 0, right? For example, I'm putting the example here. For example, you have y or f of x equals negative 7. So you would get the horizontal line. So this is xy plane. So negative 7 is down here. And you have the line, just the horizontal format. And we all know, I assume you know that the derivative or the slope of the horizontal line is 0, because when you think about the slope formula as rise over run, since the graph is flat, so no rising motion. So no change in y at all. If no change in y, it's gonna tell us that the slope or the y prime gonna be 0. Okay, the horizontal line, the slope is 0. Therefore, the derivative is 0. Another special case is just the straight line. this is just the special case. Okay, for this special case, it's just the oops, where did it go? The another straight line. The acting weight again. Yeah, think about the graph y equals x. So you have the straight line. And in the form of y equals mx plus b, mx plus b, the m equals 1 and the b is 0. So therefore, the derivative for y equals x equals 1. And the next two derivative rules, it apply to any function type. As you multiply the number to the function, the number doesn't change anything. You just treat it the same as you treat the coefficient. For example, you have the function, yeah, it's jumped. So let me write the example on the side here. So for example, you have y equals 2 times x to the fifth. Okay, 2 times x to the fifth. We already used the example, like the earlier part here. We know that the slope of f prime, slope of the x to the fifth is 5x to the fourth. So the y prime, is 2 as a coefficient, and the derivative of x to the fifth is 5x to the fourth. What you have to do for this situation, you just multiply 2 and 5 to simplify it further. So it becomes 10 times x to the fourth. First, you do not have to do anything. You just wait and see whether you can simplify more or not. You just have to work on the main function piece. If it is in a power form, you use a power rule. Bring the power down, subtract the power by 1 to come up with a new power. And the last rule is called the sum and the difference rule. If you add or subtract two functions, the derivative, you can treat them the same way. You can add them, you can subtract them as well. For example, if you have y equals x to the fifth plus x, so y prime gonna be the derivative of x to the fifth, which is 5x to the fourth, plus the derivative of x, which is 1.